Hello and welcome to another math video. Today we're going to be looking at an FST quiz for Chapter 1, Section 4 and Chapter 2, Section 1. Beginning with solving this equation, so we are starting with 4x plus 6 equals 12. So what we would want to do would be to subtract 6 from both sides of that equation. And we end up with 4x equals 6. And from there we just divide by the 4. And we get x equals 6 over 4. That, of course, can be reduced down to 3/2. Now for me, again, I prefer that fraction answer. Since 1.5 is exactly the same, I would accept that as well. But be careful about rounding answers. Again, I know for me, I don't really like to accept even rounded answers if we can have an exact form instead. Looking at number 2, we do have variables on both sides. And so for me, I would choose to take care of the variable first. And if it's up to me, I will always have that variable be positive. So I would subtract the 7t from both sides. And from there, deal with what we have left. So I end up with 8t minus 2 equals 12. Add the 2 to both sides then, so at that point there's only the one good choice of what to do. 8t equals 14, and divide by 8. Now 14 over 8 will reduce down by a factor of 2, so we get 7/4. Again, 7/4 is a great answer. I would also accept 1.75 since that is exact. But again, try to avoid rounding answers wherever possible. Looking at number 3, we have some distribution to do, really just with this minus sign. The parentheses over here around the y minus 8 are just there, they don't really do anything. We would have a minus y and a minus 2 there. So it's a little bit strange on the left hand side, we get a y minus a y, and if you wanted to you could rearrange those terms so that the like terms are next to each other. So you can see the y minus y would go away, we get negative 10 equals 9y. So all we do is divide by the 9. So we end up with y equals negative 10/9. That is a repeating decimal, negative 1.1 repeating. So I would accept that so long as you wrote it with the repeating decimal because that is exact. But again, to me it's just a lot easier, just leave that as negative 10/9. And again, I would take points off if you rounded that answer because we have a perfectly acceptable exact answer there to use instead. For number 4, we just have a bit of distribution to do on the left hand side, so we have to distribute the 12 into those parentheses. So the 12 multiplies both the 5c and the 4, and of course you could figure that out in one step, but just so we can see what's going on. So we end up with 60c minus 48 equals 8c minus 7. From here, again, I would always choose to deal with the variable first. That way I know that it's going to be positive, which makes that a little bit easier. So we get 52c minus 48 equals negative 7. From there, I would add the 48 to both sides, and we get 52c equals 41, and divide the 41 by the 52, so c equals 41 divided by 52. And that fraction does not reduce, so I'd say that's really the one good answer to have there. Pretty much any decimal you have there, you're going to have to approximate. So just leave the exact answer, 41 over 52. Alright, I had to zoom out a little bit here for number 5. Different set of directions. So besides just solving the equation, we want to decide whether the equation is a conditional equation, which is really the type of thing we've been dealing with so far. If it's always true, then it's an identity, and if it's never true, that is a contradiction. So besides determining that, we also need to give the solution set. Now with these sets, I'm not necessarily too concerned about if they're written in set notation, but I'll show you that as well. So for this first one, we really just need to distribute the 5. We get 10f minus 155 equals 10f minus 155. Now at that point you might look at that and say, there's something going on here. If you do need to go a step further, that's perfectly fine, and that's kind of the standard way that we do that. We end up with negative 155 equals negative 155. So since this is a true statement, it's always true, then this is an identity. The solution set for identities is all real numbers. So this is just one way to put that in set notation, just putting all real numbers in the set brackets. So that's what we're looking at for that one, identifying that it is an identity and that the solution set is all real numbers. And we continue with number 6 with those same directions, really. So we want to solve it, but also identify whether it's a conditional equation, an identity, or a contradiction. So we'd start by distributing the 3. Nothing really to do on the left side there. So we get 12m plus 51. So this one, right away, you can tell it's going to be conditional because the variables do not cancel out. We get 6m plus 15 equals 51. From there we would subtract the 15 from both sides. It's kind of strange how we get the 15 and the 51 there. And we end up with 6m equals 36. We divide by the 6, and we find that m is 6. So that's our solution set. And so this is a conditional. And really for the solution set, then we just put 6 in the set brackets. And for me, if you just leave it as m equals 6, I would accept that. I'm not necessarily too concerned about that being in set brackets. Again, continuing those same directions with number 7. Again, nothing to do on the left side, so we just have 15k plus 34. We do, however, need to distribute the 3 on the right, so we get 15k plus 27. Again, you may realize at this point that something is going on. One step further, we subtract the 15k, and we end up with 34 equals 27. Well, we know that's not true. That makes this a contradiction. So a contradiction, that means that there is no solution. So there's 2 ways you can show that in set notation. You can use the symbol for the empty set, which is like a 0 with a slash through it, or you can do the set braces with nothing inside them. Do not, however, put those 2 things together. It's either one or the other for the answer there. And here's our last one that we'll look at from that set where we're determining conditional identity or contradiction. It's set up a little bit differently where everything is really piled onto the one side. So that's a minus 89. And we do have to distribute the 3, so we get a 6s there as well, and a 63. Let's see, now, again, you could rearrange this if that helps you look at that. So negative 6s plus 6s plus 63 minus 89. Again, just using that commutative property of addition. So the s's will cancel out. 63 minus 89 is negative 26. Again, we all know that negative 26 does not equal 0. So another contradiction. And again, you can use that symbol for the empty set for the answer, or again, you can just put the empty set brackets. We're down to the last 2 questions. Number 9, we're going to solve this equation. Now this one does have fractions in it, so we would like to get rid of those fractions. We like to use the LCD in order to do that, the least common denominator. If it helps to think of it as the 4 having a denominator of 1, that's perfectly fine. but that LCD, in this case with 5, 3, and 1, would be 15. So really we multiply both sides of the equation by 15. On the left side we do have to distribute, and in this case it's not too tough just to multiply the 2x over 5 by the 15. You get 30x over 5. And the x over 3 by 15, you get 15x over 3. And of course 15 times 4 is 60. Oftentimes when I look at this kind of distribution here, I just think of, well, what's 15 divided by 5, which gives me 3, multiply that by the 2, which gives me 6. You get to the same point though if you do this, because really now we're just doing 30 divided by 5, which of course still gives us 6. And here I can just do 15 divided by 3, which gives me 5. It's a little bit strange because 6x minus 5x is just x, and so we end up with x equals 60. So again, that is a conditional equation, but we're not asking for that at this point. And that brings us to the last question for this quiz, so an equation involving decimals. The decimals that we do have are all to the hundredths place. So what we want to do is multiply both sides of the equation by 100. That will eliminate those decimals and allow us to work with that equation with a little bit easier numbers. And of course I'm running out of room here. So 380 times the 100 as well. So distributing that 100 through, it gives us negative 8x plus 14 times the x plus 2,500, and then the 380 times 100 would just be 380 with a couple of extra zeros, so really a 38,000. We do need to distribute the 14, which brings us to a negative 8x, negative 8x plus 14x plus 35,000 equals 38,000. Combining the x's on the left side gives us 6x. And from here we would subtract the 35,000 from both sides of the equation. And we end up with 6x equals 3,000. And so of course from there we divide both sides by 6 and we get x equals 500. Hopefully you found this helpful and it helped you prepare for your quiz. Thanks for watching.